Everything's failing.
I was compressing the audio, so I can't do anything right now.
Well, it usually will start recording, but it is recording.
Oh,
Awesome.
well. Never mind.
That's okay. So we're going to look in particular at the function sine of x divided by x. And I think we've looked at this before, but it seems my past experience has been that no matter how many times you look at it, you refuse to remember it. So,
You being us.
yes. I mean, in general, like calculus students in general. I'm going to look at that on the trig window, just because it's kind of a tricky function. All right, so by its definition, what do you expect to happen at 0? You don't know? If I plug 0 in there, what happens?
It's undefined.
Yeah, it's undefined because I'm not allowed to divide by 0, much as I might like to. All right, but looking at the picture, what do you notice is happening at 0?
Looks defined.
It looks defined, right? There's a, if we were to table this, we would see, well, let's just do that. Error. But on either side of it, it seems to be nicely defined. So what's happening here in terms of calculus is what? What's going on here? What do I have at 0, even though 0 is not in the domain of this function, but something exists at 0 that's important to us in calculus. What would that thing be?
Is it, I'm just going to throw out a word, derivative?
Nope.
Limit.
It is a limit, yes.
Yeah.
Yeah, we're going to find out eventually that a derivative can't exist in a point that's not in the domain of the function, but the limit certainly can. So yeah, and what does it look like the limit is?
1.
1. Okay. This is probably the most important limit for you to memorize. It will almost definitely pop up on your AP exam. The limit as x approaches 0 of sine x over x is 1. Okay? And now that you have that in your head forever, you're going to use that information and the rules that we just talked about to determine the answer to number 13.
So would you do like 9 divided by 5 first and multiply that to the limit of sine x over x?
You would indeed. So if you look up there, rule number 3 says that the limit of a constant times a function is the same as the constant times the limit. You're allowed to pull constants to the outside of that limit sign.
That's convenient.
So 9/5 is our constant here.
Right.
We can pull it to the front. So go from there. That's going to be the predominant sound in the audio of this.
I'm probably should move
Austin
it.
eating apple.
So that's just 9/5.
It is indeed. Yes, because that thing on the right is the limit we just talked about, which is 1. There it is. Awesome.
That was much easier.